$13 billion supercarrier, 100,000 tons of steel, 1,092 feet long, sitting on blocks inside a dock the size of a stadium. In the next few hours, America has to move it without a scratch. This is how the US Navy undocks a floating city safely. Flood in stages, free the hull, open the gate, hand control to tugs. What nobody tells you, the real danger isn't speed, it's tiny forces on massive steel. Right now, USS Gerald R. Ford sits in Dry Dock 12 at Newport News Shipbuilding. The dock is a concrete canyon, walls rise stories high. At one end, a caisson gate holds back the James River. The carrier rests on hundreds of steel blocks, positioned by laser to the inch. The keel blocks carry the weight, the side blocks keep her centered. And between those blocks and a billion-dollar hull, there's almost no room for error. The dockmaster owns this evolution, every valve, every line, every tug movement. His checklist runs dozens of steps. One gets skipped, and physics wins. Because when you're moving a ship longer than 3 football fields surrounded by concrete with inches of clearance on each side, you don't get second chances. You get it right, or you get a headline nobody wants to read. Before a single gallon of water enters that dock, the Navy certifies everything. The dock itself, the blocks, the plan, the people. This isn't a suggestion, it's doctrine. MILSTD 1625D lays out the safety certification program for dry docking facilities. If the dock doesn't pass, the ship doesn't move. Inspectors walk every inch of the structure. They check for cracks in the concrete, corrosion on the caisson gate, valve function in the culvert system. They test the pumps that will flood the dock and the pumps that emptied it in the first place. They verify measurements, because the difference between a safe undocking and a scrape that costs millions is often a matter of inches. Then comes the docking plan. Naval Ships Technical Manual. Chapter 997 governs this. The plan specifies where every block sits, how much weight each one carries, the ship's center of gravity, her drafts forward and aft, the ballast loads inside her tanks. Every number gets double-checked. The ship has to float off those blocks cleanly when the water rises. If she lists, or if one section lifts before another, the forces can bend steel or crack a block. Either one is a catastrophe. The blocks themselves are inspected before the ship ever arrived. Keel blocks run down the center line. They're built from oak or synthetic materials that can handle immense compressive loads. Side blocks brace the hull. Bilge blocks support the turn of the hull where it curves. Every block is shimmed and measured. When the carrier settled onto them months ago, teams used levels, lasers, and old-fashioned eyeballs to make sure she sat true. Now before undocking, they check again. Water pressure, ship weight, and time can shift things. A block out of place means the hull could hang up during float-off, or worse, slide. The risk is real enough that the entire plan includes float-off checks. Specific draft readings that confirm the ship has cleared the blocks safely before anyone even thinks about opening the caisson. Weather matters just as much as steel. The dockmaster won't move the ship if wind gusts exceed the yard's limits, typically around 10 to 15 knots. A supercarrier has a massive sail area. Even sitting low in a flooded dock, a crosswind can push her sideways. When you've got only feet of clearance between the hull and the dock walls, a gust at the wrong moment can cost you control. So they wait. For the right tide, for calm air, for daylight. Visibility isn't optional when you're threading a billion-dollar needle. The people get certified too. The dockmaster has done this before. The tug captains have trained for it. Line handlers know their jobs. Crew aboard the carrier stand ready at damage control stations just in case. Nobody's casual about this. The stakes are too high and the margin for error is too thin. When the dockmaster finally gives the word to start flooding, it's because every box on every checklist has been checked. Twice. The dockmaster gives the signal. Valves open. Water from the James River starts pouring into the culverts that run beneath the dock floor. It doesn't rush in all at once. It comes in controlled, measured. Because flooding a dry dock isn't like filling a bathtub. It's a ballet of pressure, buoyancy, and physics that can go wrong in a dozen different ways. The water rises slowly, a few inches, then a pause, Inspectors walk the dock floor, looking for leaks around the blocks, around the hull, around seals and seams. They check the carrier's draft markings, forward and aft, port and starboard. The ship has to rise evenly. If the bow starts to lift before the stern, or if one side comes up faster than the other, the forces on the blocks can spike. Steel can bend, blocks can crack. The whole evolution stops until the problem is fixed. So they flood in stages. 6 inches, stop, check. Another 6 inches, stop, check. The ship's ballast team is inside, monitoring trim. If the carrier starts to list, they shift ballast water between tanks to bring her level. The dockmaster is on the radio, coordinating with the ship, with the inspectors, with the yard. Every voice stays calm. Every call gets repeated back. There's no room for assumption. As the water climbs, the ship's weight starts to transfer from the blocks to the water itself. Buoyancy takes over. The hull is still resting on the blocks, but lighter now. There's a specific moment, called going light, when the ship just begins to float. You can't always see it, but you can measure it. The blocks stop taking load. The hull is free, and that moment is the most dangerous part of the whole flood. Why? Because when a 100,000-ton ship floats free inside a concrete box, even a tiny imbalance can cause movement. A gust of wind, a current through the partially filled dock. The ship could drift a few inches and contact the wall or a block. At that scale, a few inches of drift equals thousands of tons of force. Fenders help. Mooring lines hold her centered. But the truth is, control at float-off is as much about timing and conditions as it is about equipment. Once the ship is confirmed light and stable, the flooding continues. The water rises until it matches the level of the basin outside the caisson gate. Equalized pressure. The ship floats freely now, no longer touching the blocks at all. Divers go down to verify clearance. They check that the keel is clear, that the rudder and propellers have room, that nothing is hung up. Only when the diver reports all clear does the next phase begin. The dock is flooded, the ship floats. Now it's time to open the door. The caisson gate is a floating steel wall. It seals one end of the dry dock, holding back the river during construction and repairs. Now, with the water equalized inside and out, the caisson can be moved. Depending on the dock design, it's either floated out of the way or swung aside on pivots. Either way, it's a slow, careful process. The caisson itself weighs hundreds of tons. Positioning it wrong can block the exit or damage the gate structure. Yard crews handle the caisson under the dockmaster's supervision. Lines are rigged. Winches pull. Tugs may assist. Inch by inch, the gate clears the opening. When it's fully open, the carrier has a straight shot to the basin, but she's not driving herself out. Not yet. The ship's propulsion isn't tested inside the dock. There's no room for error if a shaft or rudder doesn't respond. So the Navy hands control to the tugs. 4 or 5 powerful yard tugs take up positions. Bow, stern, port, and starboard flanks. These aren't ordinary boats. They're purpose-built workhorses with high bollard pull and azimuthing drives that let them push or pull in any direction without turning. A typical tug in this class can deliver 4,500 horsepower or more. When they work together, they can move a mountain of steel with precision. Tug captains communicate with the dockmaster and with each other on a dedicated radio channel. Every movement is called out. Bow tug, push easy to starboard. Stern tug, hold steady. Port flank, pull 2 feet. The commands are specific, the responses are immediate, and the motion is glacial. Walking speed, slower than walking speed. Because when you're guiding a ship 1,092 feet long through a channel with only feet of clearance on either side, fast is dangerous. Line handlers on the carrier and on the pier manage the mooring lines. As the tugs ease the ship forward, lines are slacked, shifted, and resecured. Fenders, massive rubber cushions, hang between the hull and the dock walls. If the ship drifts even slightly, the fenders absorb the contact. They've saved countless millions in prevented damage over the years. The dockmaster watches from his station. He has eyes on the ship, on the tugs, on the weather. A sudden gust can push the bow or stern out of alignment. If that happens, the tugs compensate, but only if they're given time. That's why the whole evolution moves slowly. Speed equals momentum. Momentum equals risk. Control beats power every single time. Spotter teams stationed along the dock walls watch the clearances. If the hull gets too close, they call it out. The tugs adjust. The ship creeps forward, foot by foot, minute by minute. It can take over an hour to move the carrier from the dock into the open basin, and every second of that hour is choreographed. Finally, the stern clears the caisson. The ship is out of the box. Free water surrounds her. The tugs maintain their grip and guide her toward the outfitting pier. The danger isn't over. It never is when you're moving a supercarrier, but the hardest part is done. The $13 billion asset is out of the dry dock, safely. The systems matter. The checklists matter. The tugs and the blocks and the caisson all matter. But at the end of the day, an undocking evolution lives or dies on human judgment. The dockmaster makes the final call on every step. The tug captains read the wind and the water and adjust in real time. The line handlers feel the tension in the ropes and know when something's wrong before the instruments do. These aren't rookies. The dockmaster has supervised dozens of dockings and undockings. He's seen weather turn. He's seen equipment fail. He's made the call to hold when everyone else wanted to push forward. Because the cost of waiting is measured in hours. The cost of moving too soon can be measured in millions, or in lives if something catastrophic happens. Tug captains train for years before they're trusted with a carrier evolution. They know their boats. They know the basin. They know how a crosswind will push a hull that size and how much power it takes to counter it without overcorrecting. When the dockmaster says hold steady, they hold steady. When he says ease back 2 feet, they ease back exactly 2 feet. The margin for interpretation is zero. Line handlers work in teams. They're stationed on the carrier's deck and on the pier. When a line needs to be slacked, shifted, or secured, they move fast but never rush. A fouled line can jam. A line under too much tension can snap. A parted mooring line is a whipping steel cable that can cut a person in half. So they watch, they communicate, they trust each other, and they execute. Holds happen. A weather system moves in and the wind picks up. The dockmaster calls a halt. The ship sits in the flooded dock for another 6 hours, another 12 hours, however long it takes for conditions to improve. The crew waits. The yard waits. Nobody complains because everyone knows the alternative. Moving a supercarrier in unsafe conditions isn't brave, it's reckless. And recklessness has no place in an evolution this precise. There are no cameras inside most of these decisions. No interviews with the dockmaster while he's weighing wind speed against tide windows. No dramatic music when the tug captain makes a micro adjustment that prevents contact with the wall. The work is quiet, professional, repetitive in the best possible way because repetition means the system is working. But make no mistake, this is where the mission succeeds or fails. Not in the engineering drawings, not in the contract specifications. In the judgment of men and women who've done this enough times to know that slow is safe, that patience is strength, and that the only call that matters is the right call. The carrier clears the caisson. The tugs guide her across the basin toward the outfitting pier. It's a slow turn, a careful approach. Even in open water, the process stays controlled. When the hull comes alongside the pier, line handlers on both sides work together to secure her. Massive mooring lines loop around bollards. Fenders compress between steel and concrete. The ship is fast to the pier. The tugs release their lines. Their job is done. The dockmaster signs off on the evolution. After hours of coordinated movement, checklists, and holds, the supercarrier is exactly where she needs to be. Out of the dry dock, secured pierside, ready for the next phase. And that next phase matters. The undocking isn't the end. It's a milestone. With the ship out of the dock and at the pier, systems testing can continue. Power plant trials, electronics integration, crew training evolutions, the work that turns a hull into a deployable warship. Eventually, she'll cast off those pier lines, fire up her reactors, and head out for sea trials. But none of that happens without this step, without the undocking, without moving a $13 billion asset safely from a concrete box into open water. What makes this possible isn't just the hardware, it's the discipline, the doctrine, the willingness to wait for the right conditions, and the skill to execute when the moment comes. It's the dockmaster who won't cut corners, the tug captain who knows his limits, the line handler who's done this 100 times and treats the 101st with the same respect as the first. We build supercarriers because our nation needs them. We move them safely because we respect what they represent. Every undocking is a test of precision under pressure. Every successful evolution proves that we can handle billion-dollar steel with inch-level care. And every time a carrier clears the dock and reaches the pier without incident, it's a quiet victory that most people will never see. If you respect the skill it takes to move a floating city 1 inch at a time, you're exactly who we built this channel for. Subscribe to the Navy Intel for more deep dives into the engineering, the people, and the missions that keep our fleet ready. Drop proud of our Navy in the comments so the teams who do this work know you see them. We'll see you in the next one.